So we left here in question number 7, find the probability for a fair die is rolled. What is the probability of rolling a 1 or a 4? So we have the probability of 1 or 4. So these are called mutually exclusive events because they don't depend on each other. So you have the probability of 1 plus the probability of 4 of landing a 4 in your die. So the probability of landing a 1, if you throw the die, is 1 out of 6. Plus, you have another landing a 4, a die. There's only 1 4 in your die, so it's also 1 out of 6. When you add this, you get 2 out of 6. You should know how to add fractions. And lastly, you don't want to leave your answer as 2 out of 6 because you could reduce. They're both divisible by 2, so you want to reduce. This becomes 1/3. So the probability of rolling a 1 or a 4 using a fair die is 1/3. Okay. What is the probability of not red given? So if I give you a bag that contains 8 blue marbles, one green marble, and 3 red marbles. Remember, when you're not red, the probability of not the event is 1 minus the probability of the event. So what 1 is our total? Or what is our total in this case? 8 plus 3 plus 1, that looks like 12. So 12 out of 12 minus the probability of landing a red. How many red marbles do we have? We have 3. 3 out of 12. This is the probability of not red. So if we have the 1 became 12 out of 12 because that's our sample space. We have 12 marbles in total. So we get 9 out of 12. But again, we want to reduce. They're both divisible by 3. So we get 3 out of 4. This is the probability of not red. We do 1 minus the probability of the event. This is the formula that you should also have in mind. All right, let's move on. Question 9, find the probability given a family of 7 children. There's 7 children. The probability of having a boy is a half, right? Because you can either have a boy or a girl. That's it. So they're looking for what is the probability of having 4 boys followed by 3 girls. Well, 4 boys, 1, 2, 3, 4. So the probability of having a boy, they're all independent events. This is what it's called, independent events. Times now followed by 3 girls and a girl, right? Because there's 7 total. What is the probability of having a boy? 1/2. What is the probability of having a boy? Same, 1/2, 1/2. What is the probability of having a girl? Well, if it's not a boy, then it's a girl. So then this is also a half, and a half. So technically, find the probability is 1/2 raised to the 7th power. Okay. So that's 1 raised to the 7th, 2 raised to the 7th. We get 1 over 128. This is the probability of having 4 boys followed by 3 girls. In reality, the order doesn't matter because the probability of either having a boy or a girl is the same. Okay, they're all both a half. So it depends on the family size, technically, in this case. So it's 1/2 raised to that family size, 1/2 raised to the 7th. So the probability is 1 over 128. This is because they are independent events. So you want to make sure that you're using the formula for independent events. They do not depend on each other. Okay. the probability stays the same. All right, so the last question, number 10, is find the conditional probability. A bag has six blue marbles, 3 green, and 5 red. You select 2 marbles, 1 at a time, without replacement. This is key, without replacement. Determine the probability that the first marble is blue and the second marble is also blue. So you have a total of 14 marbles. So 6 plus 3, we get 9. 9 plus 5, we get 14 marbles total. Okay, so our total is 14 marbles. Now, the probability of selecting a blue marble is 6 out of 14. That's if you selected the first time around, right? Because you have 6 blue marbles. Now, if it says you're selecting a blue and then a blue again, but without replacement, what is without replacement? So you're taking it out and you're not putting back the marble. So technically, let's say this is our, you're drying it from this container and you have 6 blue marbles. So let's say 1, 2, 3, 4, 5, 6 blue marbles. You have 5 red, 1, 2, 3 red, 3, 4, 5 reds. And then you have 2 green marbles, 3 green, 1, 2, 3. So the first draw, you're selecting 1 at a time. The first one you select out is 6 out of 14, right? That's your first choice. So you're taking it out and you're replacing it. Now you only have 5 marbles to choose from, 5 blue left. Out of how many marbles? 1, 2, 3, 4, 5, 6, 7, 8, 13. So the next probability is 5 out of 13. So to do that, these so the events are dependent events because you're doing it without replacement. So you find the probability of the blue times the probability of a blue selecting a blue again. So you have 6 out of 14 on the first draw times now 5 out of 13. And then you can either simplify. If you can simplify across, it doesn't seem like you can. So you multiply 5 times 6, you get 30. And then 14 times 13, whatever that is. Again, you are allowed to use your calculator, 182. And it looks like they're not divisible because 30 and then 1, 9, 11, nope. There's nothing you can simplify. So your answer is 30 out of 182. Okay. So the more you practice, the better. Again, this is only a brief review that I do prior to your quiz. It's just for additional help to help you understand what does it mean to be with replacement, without replacement. That's very important. So please make sure you look over your notes and you review before taking your quiz. This was sections 11.1 through 11.3. So please make sure to study before you attempt this quiz. Thank you, and I will see you next for the next video. Thank you.